initially, but they can get a lot of data this way.
But I didn't understand what is what kind of sensor has been installed?
The plan is to install primarily RGB cameras. Multispectral are way too expensive.
So for now it's just a project.
Yes, and
It's been funded.
it's going to be proposed in probably in the next few months. We missed the last deadline, and since COVID started, these calls are becoming have become pretty scarce. So we haven't had the opportunity to launch that, and we have a team built from hydraulic engineers, hydrological experts, experts on software, hardware, and we can. That's something that we aim to provide. Unfortunately, we fear that this is not something that's going to catch an eye for some Horizon Europe project. We don't have much to show at this moment, so the idea was to launch a national project, which is about the same amount of money, but we don't have to
Compete that you
yes, we don't have to compete, and we don't have to achieve significant TRL. We can aim for something below or at level 4. So we need to have a few pilot stations for this first project and afterwards. But the idea is to allow people to see in real time this data, to process that data, and to allow them. This is one of the ongoing problems, and it's becoming more serious over time. Our National Meteorological Service has financial problems, so they're trying to get as much money as they can for every byte of data that they send. So the idea was to set up these networks and also to provide that data for free for research and for anyone who needs it. And the idea was also to share that data with all our international partners if they need anything for research, for example.
Okay. How do you? I mean, I'm starting reading something about citizen science. No, it's a new branch that is opening now. It's becoming fancy, and everybody is using the word as now we have some years of experience, and we've seen these trends coming in and going in science, no? And this is the period of citizen science. In this context, the public engagement is very, very crucial. So, how do you tackle this issue in the project?
Well, in our minds, we understood that social involvement doesn't necessarily have to be a regular person on the street, that we can just offer them to some experts or semi-experts that are monitoring those rivers, and we can create a call and get them to train on building the hardware, because the hardware will be like an open source Arduino Raspberry Pi and the sensors that we can get, and to create a product as cheap as possible, and to train them on creating the hardware and using the software that we're going to provide.
We've done a little bit of this in Newcastle. Matt had a station in the Lake District, and he targets people, or he targeted a person who lives next to a river that floods recently, quite often. And he was very keen. Like, people are very, very keen when it happens to them, when it floods their houses. They're very keen to get involved with things like this. And he kept up all of the equipment. He was constantly asking questions. Never too much,
Yeah.
but that works quite well. But then you still got to devote quite a bit of time to the people who are involved.
Well, it's, Robert and I were talking about I've had the similar kind of idea for in Texas, where I got my master's degree, is Flash Flood Alley in the United States. It's thin soils over limestone bedrock, and anytime it rains, there's flash floods. And so trying to develop, my idea was not a camera-based, mine was more of a pressure transducer-based, real-time GSM connected network that's real-time, maybe even just into like an ArcGIS online map database so that people can see water levels, you can sign up for alerts, integrated in with the state's hydrologic network, the USGS potentially. And I think it's the people there, and I think it's the same idea, is that people that live in those catchments want to know when the water's coming.
Yeah.
Because and in Texas especially, they're ephemeral streams, so they're dry 90% of the year, except when it rains, and then you need to know quickly where the which road crossings are covered, how much water is coming, how fast it's coming. And so my idea was to develop a dense gauge network that just
Yeah,
sits
the
in
pressure transducer is very cheap.
30
It has a great advantage.
right, and the whole system that I actually got a little internal grant from my university to
But
develop.
it has some problems when you have a lot of deposition of.
Well, so you have to build in a stilling well like a traditional gauge, but you can maintain that fairly easily. Or just attach it to a bridge here and have it and some of the low water crossings in the area that I'm thinking about, it's a concrete, roadbed. You can just, attach it to that, and it's not gonna, and even if it does wash away, it's only $200, so it's not hugely cost. The impact is huge if you lose it. And they're all gonna have, I'm gonna actually have GPS on it too, so if it stays connected to a battery, we can go find it after. But it's gonna be, the real-time network, so it's gonna be, reporting the data, so we don't have to go out and collect anything. And I think that the people that are interested in it, in the citizen science perspective, are the people who live out there and want that data.
They've got something to lose.
Yeah, but it's also from a science perspective, the way that I wrote the little seed grant was, it's also important data for regional hydrology modeling to say, okay, especially in an ephemeral stream system, and it's almost karst topography as well, so it's heavy losing gaining. Where is this water going? Where is it coming from? How's it moving? We don't have, considering this is a high flash flood area, there's still not a lot of data available, so.
I forgot to mention that, as an addition to that, we wanted to create a low-cost meteorological stations that we would primarily monitor precipitation, because that's the important factor. in all
Also
of
with the
ours.
camera.
No, not with a camera necessarily, but we had an idea and we had some plans to start building and start using cheap precipitation meters, like rain gauges. And I actually went out and talked to people in those neighborhoods, some people that I knew, about whether they would be interested in receiving those devices and just keep them powered up and maintain them. And they were like surprisingly eager to just help, because it doesn't really bother them much, and it doesn't spend a lot of electricity, and you can get a denser network at the positions where you're most interested.
Right.
Because I'm not sure about other countries. Meteorological network is pretty sparse, and for that catchment, the nearest rain gauge was 30 kilometers away, and it's pretty nasty terrain, a lot of hills, so it doesn't really reflect the data that you're going to get there.
I've built something like this already. I've got a GMX weather station hooked up to a Raspberry Pi, which is also connected to an RCB camera next to a river. And I think it cost about £2,500 for everything. And that was a rain gauge. That's a full weather station as well. So you get like brightness and wind and everything else. And that's about £2,500. And it's built over in Wales.
Yeah, I think the low cost electronics stuff has got a lot of potential for us, and
I mean, our HMS charges around 20,000 euros to set up a monitoring station. So, and an order of.
I know.
magnitude
In
below
Italy, it's the same. The cost of just an hydrometric station is 40,000. That's the actual cost. And of course, there is also the maintenance. And the biggest for just traditional stations, the biggest challenge is that, and the biggest problem is that this data is useless, totally useless, because we don't have flow rating cards. Nobody's is getting the flow rating cards, and the flow rating cards should be taken every 3-4 months. No, and you you know that this is needed.
No,
But in Italy, in the south of Italy, no way they're doing this. I mean, it was done since it was a national service. Then they moved the responsibility to the regions, and everything has stopped. Probably, and I have the perception that also there was in the 60s, there was a significant higher perception in the value of water respect to now. That's from in my country what I see. It's not what is happening everywhere. I know UK is doing okay, but in our country there has been a significant deterioration of the hydrological monitoring system. All right. So low cost may be an issue. Low cost techniques seems to be interesting.
Instead of citizen science, could you just use local authorities? Because the work I was doing in Scotland, everybody that I talked with and everybody I worked with over there was dead keen to get involved in image dosimetry stuff. Like half the time they spent working on site with me, they were just asking questions, constantly asking questions about how they can get involved more. So instead of using like community, you could just try local government. Yeah.
Okay.
I mean, that's what we kind of understood. I mean, it's a bit loose definition, but you are involved in someone who's not academia, who's not a researcher, and you're providing them with a product. And you just basically, after your grant period, you can just leave them with the hardware and just support them in a way.
That's pretty much what I've done.
It's great.
Okay, we are running out of time. I think we are almost on perfect time to close the session. So before closing, just a quick check if there is any thought to share from Daria, Jan, Silvano, Domenico, Cinzia. I don't know. Jan is raising the hand. Yes.
Yeah, I just wondered if anybody in the group had any experience if they're trying to monitor real-time or near real-time morphological change of having a suite of trail cameras in fixed positions with overlapping imagery to use those for photogrammetry, and whether that's an option that we could explore.
Yeah, I've done it on an experimental lava flow. Does that count?
Yeah, I mean, I've read about them being used on monitoring the front, the tongue, the snout of a glacier, and looking at glacial recession.
So
But I wondered if we could apply that to looking at bank erosion.
yeah, and I think we can for sure. And I think that's done some work on that too.
And this we actually planning, we are actually we install systems to detect directly, combine with even precipitation sensor, when
Right.
there's some rainfall, and also when they directly you follow continue how
The curve.
the flood,
Right.
where is happening, how it's reacting to the collapse, bank collapse, bank failure, how it
Yeah,
react to the flood.
Yeah, Ian, the one problem that I've had with that system for like 3D modeling of, I mean, if you just want to do like visual change, it's fairly straightforward. But if you actually want to like put it into like a structure for motion 3D model, the biggest challenge we have is actually there's there's a small amount of error that's induced because we're using single cameras from a fixed location, and the camera calibrations get a little bit out of whack. And so you end up with kind of a little bit noisier of a model. It's still useful, but it's not as precise as, but I mean, we're talking relative precision here. It's, you know, yeah, it's not, you know, it's 10, you know, maybe 5 or 7 centimeters versus 2 centimeters. So it's a relative precision. I have to always remind myself, I guess, we can do better than 7 centimeters, but that's fine for most things. But it's just something to be aware of, that the camera calibrations and the structure for motion with fixed multiple cameras can be challenging, but something that we can definitely start to look at a lot more, I think.
This is especially have like 1 meter bank collapse, so that
Right, exactly. We're not trying to measure like sand deposition on,
it's okay.
you know, yeah, we're looking at wholesale change. So I think it's probably fine for geomorphic change detection.
I have some experience in the measuring the erosion, but in the coastline. Using
But that's
a
easier.
couple of cameras continuously attached to light pole. So the pole, let's say 6-7 meters, seeing the same sketch. We collect the data for 2 years, and we follow the change and of the shoreline. We connected this with the sea wave.
So it was an oblique camera.
Yes, oblique camera, 2, not only 1.
Okay.
And wondering if also for river you can, your camera is too low, in my opinion.
Yeah, to look for the morphology.
Despite the surface, also for the morphology, but also for the water quality. I think, this is my opinion. You need to think to rise up the camera, or another option is to use, it's possible to find in the market low cost LED, like, so the idea is this.
Yeah.
If you put in the bottom something, and the camera is let's say in the vertical, when it's changing the concentration, it's an active sensor, but you can build in a low cost way. So in Alibaba, I found this in this moment. So this is some idea if you want, of course.
No, this is nice. I like it.
Like this. What? This? It's changed.
People, I don't know. No, they can see.
Yeah,
No,
it's on. Yeah,
it's great. It's great.
We have wine too and beers.
It works also with wine. There are someone that is using these techniques to measure the color of the wine.
Mhm.
Yeah.
Okay, this last sounds intriguing idea. Real-time morphological changes, active sensors. What I miss?
It's the same idea of also YAR. YAR is using
Yeah, sure. Can you share it?
Yeah.
Okay.
I'll get on.
Do you have the connection?
Yeah. Let me get on. So I was teasing some of the experimental lava flow stuff to Laszlo and Salvatore. So let me get on real quick.
Do you have the link?
Yeah, it's somewhere in my email.
I can just send you what's up.
question.
I got it.
Okay, before closing, let's give James the chance to share this video. This looks very nice. As an experiment for a real-time morphological change monitoring of a lava flow, but
Lava.
I think
Yeah,
it's lava.
it's okay. So the background is this is at it's called the Syracuse Lava Project at Syracuse University. So they actually have a blast furnace where they melt basalt and pour it out onto a test bed to test.
Really?
Yeah. 1200 degree lava with cameras right around it. Yeah.
My God, that's really only in America can.
It's a collaboration between the art department and the earth science department. So
Okay.
let me.
We have volcano.
Yeah.
We can do volcano.
I can't afford too many cameras, but we can build volcanoes.
And there is the actor at this moment is acting, so you can.
So it's cheaper. You may lose someone during the experiment.
Whatever.
Okay, so the background here is
No, bellissimo.
so this is the experimental setup. So the blast furnace at the back, and then that's basically a real fine sand bed, and we can do a lot of different things with it, or they can do a lot of different things with it. But I made these. So these are all Canon digital cameras with basically a radio trigger, so they can all fire simultaneously. I've actually miniaturized this after this project, but so we had 10 cameras placed around the whole site. And we had to wrap them in foil so that they wouldn't get melted. So heat shields basically, with a little hole cut in the front so that the camera can see out. Anyways, so the
Wow.
okay, full screen. There we go. All right.
Wow.
So this is the 10 camera time lapse in Agisoft.
Yeah.
And so here's the sparse point cloud from Agisoft in time lapse, and then it'll go towards the dense point cloud. There we go.
Wow. So the dense point cloud is working with the thermal data.
No, so that's the
No, it's
that's just-
RGB.
It's
yeah, it's
RGB.
just RGB. So that the luminescence is just the lava. being
Okay, so
soft.
it's RGB. Okay.
Yeah. And so what we can do with that, since we have the timestamps and the 3D data, we can actually get volume and flux measurements and
Yeah.
cross-sectional measurements.
So so you build a big oven to produce this lava.
So my colleague Hannah, who works for the USGS now, is actually interested in how lava interacts with obstacles for like planning and kind of defense, lava defense. Think about it like that. And so we did a number of lava cores for this and tried to do volumetric and flux measurements on these. So, but yeah, applying this to rivers should be fairly straightforward.
That's impressive.
We tried to publish it in GRL, but got rejected and it kind of stalled. So, okay.
Okay.
All right. So thank you so much.
It's in
I think,
YouTube.
Yeah, we are all trying to get this channel to save
To share the
to
difference.
save the video for the students. Very instructive. So thank you, James. Really appreciate it. I think if there are no other questions, I think we collected most of the comments and opinions, and we'll try to summarize tomorrow. So I'll see you tomorrow morning. Right. Any comment? No. It's fine. Thank you. Have a great day. Good evening.
Thanks, everyone. Thanks, Tori.
Oh. Bye bye.
Bye bye.